Okay guys, so here we are with lesson 11.6, and this is on volumes of pyramids. So a pyramid is, just as a reminder, has one base. It only has one base, and then all the other faces come together to common vertex. So let's take a look at the formula. The formula for volume, again, volume is how much space you're filling up, is 1/3 base times height. Remember, capital B is the area of the base. So this is very similar to what we just did. The only new factor is this 1/3 here, sorry. So 1/3 times the area of the base times the height. And if we were actually to do this in school, I have a pyramid that has a square base, and then I have a cube that has an equivalent square base. And when we fill this pyramid up, so like it's more or less upside down like this, when we fill it up with water and then pour it into an equivalent cube, it's pretty cool to see that it actually is 1/3. So you can see that it fills it up about that much, which is pretty neat. And so if you happen to have any of those things at home, you can try it out. But the good news is here, our formula is everything we've already known. We just throw 1/3 in front of it. And then just like before too, it can be slanted as we saw with Cavalier's principle. So that's an option as well, as long as it still has the same cross-sectional areas going all the way up. And so even if it's slanted, the formula still applies. So let's try a couple. Here they're just giving us information, find the volume. So I'm just going to write it here so we have it. 1/3 the area of the base times the height. When I look at my base is a triangle. So I'm going to find the area of this triangle first. So I'm going to do that over here to the side. And we had been calling it this, capital B, so it represents this here, but putting a little a. So you can write it like that, or capital A with little b, or just, that's kind of irrelevant. It's for your own notation. But we know that the area of a triangle is 1/2 the little base times the height. So in this case, the base of this triangle, if I were to redraw that base there, that's a right angle there, that's 4, and that is 6. So it's going to be 4 times 6, and so 1/2 of 24 is 12. And I can label that meters squared. We're finding area. So now when I substitute all of this back in, I have 1/3. The area of that base was 12, and the height references the height of my entire pyramid, which is 9. Okay, I'm going to multiply all those together. I can do a little canceling. I can see that 1/3 of 9 is 3, so I can cancel those things out. So the more you can do without typing stuff in, the better. And then from there, 3 times 12, 36. Now when I label this, it's meters cubed, because again, that's if I were to divide those into cubic meters, because we're talking about volume, that's how many I would be able to achieve. Okay, nice work. Let's go on to the next problem. Find the volume again. We're just going to practice these just because sometimes new circumstances show up and we don't want to get blindsided by those. All right, so the first one, we have a square base, and I know that for a few reasons. There's a right angle right here, and they show me these tick marks. So there are 4 congruent sides with a right angle at one of the vertices, this vertex, so it is a square. So that's convenient. So when I go to find the area of this square, it's going to be simple. So the area of my base, or the capital B there, is going to be 100. So if I put that into the formula, 1/3 times the area of the base times the height, 1/3 times 100, and the height is 12. So that's going to be 1/3 and 12 gives me 4. And so I can multiply those together and easily get 400 centimeters cubed. That one wasn't bad at all. It's pretty straightforward. Now number 2 is going to involve quite a bit more, and that's where you're going to see it's important to always take a look at a variety of scenarios. So one, this is going to involve that Cavalier's principle. It doesn't do anything different on our end though. We're still going to use the formula 1/3 the area of the base times the height. And now I look at my base and I see it's a hexagon. So let me actually draw that out. Oh, didn't change color. Okay, so I have a hexagon, and it's a regular hexagon. That's a critical. So each of my edges are 12 centimeters. So I'm going to mark that. Now I need to find the area of this. So what we learned in an earlier lesson is that we can divide this into equivalent triangles, and I would have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So if I can find the area of one triangle, I can just go ahead and multiply that by 6. And that's going to be our goal here. Okay, so I'm going to find the area of one triangle. So this is what I'm focused on. So let's see what it is that we've been given. First of all, I know that this is 12. This entire bottom along here is 12. We also learned that we take 360 and divide it by how many sides we have. So in this case there are 6. So 360 divided by 6 gives me 60. So that means that this angle measure is 60 degrees. Okay. Now, to go ahead and find the area of this one triangle, I'm going to have to find the height. I know the base is 12. I have to find that height there, and then that's going to cause me to go ahead and break this triangle even further, just looking at 1/2 of it. So right now I'm only looking at this half of that triangle, okay? And when I do that, no longer do I have the full 60 degrees, I only have this little angle here, which is 30 degrees. I do have a right angle, and so that makes this 60 degrees. Okay? All right, and then my bottom along the side, since the whole thing used to be 12, this is only 6 centimeters, I can label it. And again, my goal is to find this height. That's what we're searching for here. So let's take a look at this. There's a lot of ways to do this. If trig comes to mind, that would definitely work. We can't use Pythagorean theorem. We don't know the hypotenuse. But what we also could use is maybe you're remembering, oh, there's that special ratio for a 30, 60, 90 right triangle. And if you remember that, that works as well. That says if we know the little leg, the hypotenuse is double, and the long leg is the little leg times the square root of 3. Maybe you remember that. So that's what this value is right here. But let's just say, I'm going to write that in so we have it, 6 root of 3, that's this distance, which is actually this distance, which if we go all the way back is this distance. But another thing you could have done, we could say, well, we want this here. We can say from this 30-degree angle, I could say opposite over adjacent. I could have done the tangent of 30 equals 6 over x, if I had called this height here x. And then that would have given me my answer as well. Okay, so, or I could have taken it from this 60-degree angle and said the tangent of 60 equals x over 6, opposite over adjacent. So opposite from this angle would be the unknown over the adjacent 6. So my point here is that there's a lot of ways of thinking of it. So if you're one of those people and say, I don't know what to do, there's not one way to do it. Okay, so feel comfort in that. All right, so moving on. I have a lot of stuff on the screen. I'm going to erase some of these things just so we're not working through too much. We already figured out that height, okay? So I'm going to go back to this triangle that we had worked with initially, this one here. I'm going to label this as 6 root of 3. This bottom is 12. Okay, so let's find the area. Let's erase that for the time being. Let's find the area of just this purplish triangle that I have. Okay, so the area, or we had been calling it, yeah, I'll just keep it capital A, is 1/2 little base times height, which in this case is, oops, that's an equal sign, 1/2 of 12 times the height, which is 6 root of 3. All right, half of 12 is 6, so then I have 6 times 6 root of 3, so it's 36 times the square root of 3. Now that's the area of one triangle, but how many triangles make up that full base? Remember, that's what we're talking about. And here we said there's 1, 2, 3, 4, 5, 6. So now I'm going to take my one triangle, multiply it by 6. So it's 36 square root of 3 times 6, and 36 times 6 is 216 square root of 3. So this is the area of my hexagon. That's what we've just figured out. You can see how this problem here is way different than that one we just did, right? That shows quite a discrepancy. It's the same concept, but there's just so much more work involved because of what our base is. All right, so now I have the area of my base. We can carry this up here. So my volume is 1/3 times 216 square root of 3 times the height of this, which is 20 centimeters. And I can multiply all that together. Okay, so 1/3 of 216 is 72. So I'm going to get, and then 72 times 20 is going to give me 1,000 440 times the square root of 3. Now if they want you to give an exact answer, you could leave it like this, centimeters cubed, or you can go ahead and evaluate that. So we have an answer that kind of gives us more understanding of it, and that would be 2,494.15 centimeters cubed. Either of these answers is sufficient, okay? So anytime you're doing a problem, just see what the directions are asking you to find, and that'll help out, okay? All right, we're going to go into the next problem. So let's see what we have here. Example 2 says using the volume of a pyramid. So here we're going to solve for unknown lengths. So originally, Khafre's pyramid, I'm not sure how to pronounce that, I'm sorry, I should know. But it had a height of about 144 meters and a volume of about 2,218,800 cubic meters. Find the side length of the square base. Okay, so we have a pyramid here. Now, what we do know is we know that the formula is 1/3 the area of my base times the height. When I substitute in what it is that they've given me the height, which is 144. They've given me the volume, 2,218,800. I know 1/3. I don't know the area of the base, okay? All right, so I'm going to take 1/3 of 144, so 144 divided by 3, and I get 48. So that means now I have 2,218,800 equals 48 times the area of the base. So I'm going to divide both sides by 48 now. When I look back at this next year, whenever we come to this chapter, I'm going to see this horrible scratch work, and I'm going to think, what in the world? And obviously I will know why. It's because I'm writing with a pen on here. It can be a little trickier, but it just looks funny. So thanks for bearing with that. We have 46,225. That's the area of my base. Now that's not what they're asking. They're asking for find the side length of the square base. Okay, so we know that our base is square, which means that all of our sides are congruent. So if the area of this entire base is 46,225, to find the area of that, I'm going to take the square root of 46,225. Okay, and that's going to give me one side. So really now I would take the square root of this, and I get the side is one side of my base equals 215, and we're talking meters. So approximately, they say that. So there we have it. Okay, so that's a pretty cool one. It's nice that it worked out nicely as well. Okay, all right. Let's take the last one here, and then we'll do the rest of this lesson in the following video. There's not much more that is to come. But example 3, similar concept. They're giving us pieces. We have to fill in the blanks. So find the height given all the information that we have. So volume is 1/3 the area of the base times the height. We're trying to find the height. So I'm going to substitute in the volume, 14 square feet or cubic feet. The area of my base. Now I have a triangle, so as soon as we see anything that's not a square, it can be a little daunting. But luckily, they're giving me the height, 3. They give us the entire bottom of this triangle, 4, and they showed us that was the height with the right angle. So the area of this triangle is 1/2 base times height, 1/2, 4 times 3, so 1/2 of 12, so it's 6. So the area of my base is 6 square feet. Remember, area is always squared. All right, so I'm going to put a 6 in here for my capital B, and I don't know the height. All right, so 14, 1/3 of 6 is 2. I divide both sides by 2, so the height of this is going to be 7 feet. We've solved for the unknown. Nice work. All right, we're going to continue this lesson, but it's going to show up in a different video, okay? All right, so pick up with me in just a moment.